general power functions. Okay. The quotient rule can be used to extend the power rule to the case where the exponent is a negative integer. Suppose you have a negative integer as exponent of x. The claim is that power comes down as it is and the power is reduced by negative 1. So this is true even when your exponent is negative. Let's see. Well, look at 1 over x. This is what is x to the power negative 1. By the rule, negative 1 should come down and power has to reduce by negative 1. So from negative 1, you get to negative 2. So derivative of 1 over x is negative 1 over x squared, that negative. Alright. Likewise, 6 over t cubed. 6 is out simply because it's constant. So I'm left with 1 over t to the power 3 or t to the negative 3. So negative 3 comes down and the power reduces by 1. Okay. So reduces by 1 to negative 4. So that's negative 18 and that is over t to the power 4. So you could have used quotient rule, but power rule makes things easier. Okay. In a general, if n is any real number, notice n could be fraction, n could be any real number, could be irrational. Power rule holds true. N comes down and power reduces by 1. So for instance, here is square root t a plus bt. A and b are some numbers, real numbers. You could use product rule, right? So that is one at a time. So take square root t outside, derivative of the second piece plus second piece as it is derivative of the first piece. So this gives me a being constant doesn't give me any derivative, just gives me 0. This is derivative is b because t, derivative of t is 1. So root t times b, that's what I get from the first piece, plus a plus bt as it is here. What is this? This is t to the power half. Half comes down and half minus 1 is negative half. So you have all of this b root t plus a plus bt over 2 square root t. Alright. So all they have done here is now combined this with this. Common denominator requires 2 root t, 2b and 1b gave me 3b. Okay. Root t gives me a t. So basically you can check for yourself that this is your derivative. Likewise, use the loss of exponent to rewrite. So you could have done this differently. First multiply it out, you see, and you multiply it out. Now here is t times root t, that is t to the 3 halves. T square root t is t to the half. Now you can directly take derivative. So half comes down, reduces by 1. 3 halves comes down, reduces by 1. So this is something you could have done instead of using product rule. Alright. So you can use either rule and you get the same answer. The differentiation rules enable us to find tangent lines without having to resort to the definition of derivative. Definition of derivative, if you remember, is a long definition. It's kind of hard work. Limit h approaching 0 and so on and so forth. But these rules get us quick ways of finding derivatives. Now, once you know how to find tangent line, then you can also find normal line. What is normal line? Normal line to a curve C at a point P is the line through P that is perpendicular to the tangent line. So normal line, the only difference between normal line and tangent line, their slope. Tangent line, perpendicular to tangent line is normal line. Otherwise, both of them go through the same point P. Okay, so question is, find the equations of tangent and normal line. So this is your curve. It's a complicated curve. If you use limit definition, it will be rather difficult. So let's use just the formula, and the point in question is 1/2. Make sure when x is 1, what happens? I get upstairs square root 1, 1. Downstairs I get 1 plus 1, 2. So half. So that is indeed a point here. Question is to find tangent line and normal line. Let's first find derivative, which gives a slope of tangent line. Derivative. This calls for quotient rule. Square of the denominator right away. Derivative of the top, denominator as it is, minus top as it is, derivative of the denominator. So that gets me derivative of the denominator. This is x to the power half. So that's a fraction. Half comes down. You should check for yourself. This is the derivative you get. Minus. This is fine. And this is 2x. That's fine. When you simplify all that, check for yourself, you get this. Okay. So the point is slope. I have to plug in x equals 1 in my derivative formula. When you plug it all in, you get slope to be negative 1/4. This is for the tangent. So derivative gives you slope of the tangent. So now I use this slope and this point, right? This point, this slope to find equation of tangent line. Y minus y coordinate equals slope times x minus x coordinate. Simplify this, you get this. What about the normal line? Normal line is perpendicular to the tangent line. So, slope of the normal line will be negative reciprocal. Remember, perpendicular lines, slopes are negative reciprocals of each other. So, if this is slope of tangent, slope of normal is negative of negative, positive, reciprocal of 1/4 is 4. That's all. So equation of normal line is, I'm going to use slope for the same point. Simplify. Look, normal is perpendicular to the tangent, and that's how it looks like. Okay. So to summarize, a table of differentiation formulas. Derivative of constant, 0. Derivative of power comes down and reduces by 1, no matter what the power. Constant times function, its derivative, the constant comes out. Take the derivative of the function alone. Sum or difference, derivative goes through each of the pieces. Alright, derivative of f plus g is f prime plus g prime. Derivative of f minus g is f prime minus g prime. Product rule, you go through first as it is, derivative of the second, plus second as it is, derivative of the first. So you're going through each piece. Quotient, denominator square, derivative of the top, bottom as it is, minus numerator as it is, derivative of the bottom. Okay, so that completes the lecture slide for section 2-3. Next videos will cover problems from web work. Until then.